All right, IM2 classes. Today we are going to start factoring polynomials. First thing we are going to be doing is GCF. What GCF stands for. Why is this not? There we go. Okay. GCF stands for greatest common factor. So we're going to be looking at polynomials and finding the greatest common factor between the terms. And then we're also going to do factor by grouping. What factoring is? Here's a question because we're going to start factoring. Factoring is when you split split a quantity into two smaller quantities that multiply together to get the larger one, right? So for example, we'll start off, let's say if I told you to find the factors of 6. Do a little factor tree, 6 factors into 2 times 3. All right, we're finding the two smaller numbers that multiply together to get 6. Here, when we factor this, what we are doing is we are factoring this whole quantity. We are going to find the two smaller quantities that we multiply together that would get us this, right? That's what we mean when we say factor. We are splitting up a larger quantity into its smaller pieces that multiply together, all right? So for this, 9x squared minus 15, what we're going to be doing is finding the greatest common factor, GCF. What that means is I want the largest quantity that can divide 9x squared and 15 evenly. If you're good at this, you can do this in your head. Very easy to do this in your head when you're good at it. So the largest thing that divides 9 and 15, the largest factor they have in common would be 3. 3 divides 9 and 3 divides 15. If you're not, what you want to do is expand these. So what I'm gonna do the steps, what I think about in my head. So 9, that factors to 3 times 3. 15 factors to 3 times 5. And what I like to do is I rewrite these. So the 9 is going to split into 3 times 3, and I'll expand the x just because it's good practice, x times x. And then 15, it'd be 3 times 5. So I'm replacing the 9 with the 3 times 3, replacing the 15 with the 3 times 5. Then I look for what each factor has in common. So I got a 3 here and a 3 here. So for every part they have in common, I put one of those on the outside, the parentheses, and I cross that out. Nothing else in common, so I'm done. I just bring everything else together. So it's 3 on the outside, and then 3 times x times x is 3x squared minus just 5 left over there. That is factored. So again, what we did, we took our 9x squared minus 15, and it's like a little factor tree. It splits into 3, and then 3x squared minus 5. You can also think of it as a reverse distribution, right? If we were to distribute the 3 back into the parentheses, it would end up as 9x squared minus 15. But here is the factored form. All right, so let's do another example. 2n cubed plus n squared. So what I'm going to do is rewrite this. There's no numbers to expand, but here, so it's going to be 2n times n times n, be the n cubed, and then n squared is n times n. And so I'm going to look for what they have in common. So there's an n and an n, so I'm going to put an n on the outside, cross that out, and then they have another n in common. So another n, another n. I'm going to fix that. Whoa, not what I wanted. There we go. So the n here, so another n on the outside. And then nothing else in common, so there's a 2n here, nothing left over here. So I can multiply this out. N squared, or n times n is n squared. And left, there's 2 times n in here. Plus, we took everything out. What you need to remember is that invisible math, like in front of this n squared, there's a 1 there. So there's a 1 here. So if you take out all the factors, there's still a 1 left over. Oh my God. Okay, yeah, so there's still a 1 left over. And again, you want to think if I were to distribute this, n squared times 2n would be 2n cubed, n squared times n, 1 would be 2n squared. And again, what we did, we took this larger quantity, right? If we factored it into its smaller quantity, so n squared and 2n plus 1. We just split it up into the 2 smaller things that multiply to get this. All right, let's do one more. Not here. So first, I'm going to do a factor tree on the 14. So 14 splits into 2 and 7. 16, a lot in the 16. So 16 would be 2 times 8. And then 8 is 2 times 4. And then 4 is 2 times 2. As you get good at this, you'll recognize what they have in common. You won't have to go all the way down, but I'm going to expand it fully. So I'm going to put things back in. So 14 is 2 times 7, and then x to the 5th. 1, 2, 3, 4, 5. Plus 16 is 2 times 2 times 2 times 2. 1, 2, 3, 4 2's at the bottom there. And then 1, 2, 3, 4. Whew. Now I'm going to look for what they have in common. So they have a 2 and a 2. So I put a 2 on the outside. I'm going to just look at how many x's they have in common. So this has a fewer one. So there's 1, 2, 3, 4. So they have 4 x's in common. So instead of just doing each x individually, you can get 4 x's here. So I'm going to take out 4 x's. 4 x's is going to be x to the 4. Right? And then bring it all back together. So 2x to the, or x to the 4th times 2, I'm going to write that in the order we're used to seeing it. So it's be 2x to the 4th. There's a 7x left over here. Plus 2 times 2 times 2 is 8. So there is our factored form. All right, the assignment today is from a worksheet. So you would do, in class, we're going to be doing a bunch of factors here. Next one, we're going to be doing the same thing, factoring using GCF, but we're going to do what's called factor by grouping. So what we have here is 4 terms. We're going to factor this into 2 smaller parts that multiply to get there. First thing we're going to do is group the first 2 terms and last 2 terms together. So first 2, last 2 get grouped together. Factor out the GCF, the greatest common factor from each group. All right, so here I'm going to expand this. So it's going to be 3n cubed is n times n minus 2 times n plus this one is going to be 3 times n minus 2. Look for what they have in common. So here, looking what they have in common, they have n's, 2n, so I'm going to cross that out. So it's going to be n squared on the outside. Here, same thing. This one, they don't have anything in common, but for the purpose of this, we still want to factor something out. So what they do have in common is we can say they both have a 1. Right? We can put a 1 in both of these. Let me get some extra space here. So say I can still put a 1, multiply 1 in there, give them that little bit of invisible math there. They each have a 1. And so I'm going to take out that 1. Say they have a 1 in common. So it would be times 1 on the outside. All right. So I'm going to rewrite it. So it's n squared plus 1 on the outsides of those. And then left on the, left on the inside, there's going to be 3n minus 2. So there's 3n left on this term, minus 2 over here. This one just still has a 3n minus 2. And then what you want to do at this point, you can check to see if you did the greatest common factor correctly. If you notice on here, 3n minus 2, 3n minus 2, we want the parts that are in parentheses to match. All right. So we did step 2 here. Now regroup the factors, step 3. What I'm going to do is group the factors on the outside here. So the n squared plus 1. And then those get grouped together. And then you bring down one of these. So 3n, 3n minus 2. So that is the factored form. So this big polynomial, 4 terms, factors into 2 binomials. If we were to do the distribute this, so n squared times 3n is 3n cubed, n squared times -1 is that's not 1, that's a 2, would be -2n squared, and then 1 times 3n is 3n, 1 times -2. So it's that split and distribute backwards that we did with the multiplying part. It's that split and distribute backwards. So let's do another example. So I'm going to do first 2 terms together, last 2 terms together. I'm going to then split this up. So 9 is 3 times 3. So 3 times 3, and then n cubed is 1, 2, 3 n's, plus 3 times n squared, plus 6 is 3 times 2. So 3 times 2 times n, and then plus 2, that's just going to be 2. Now I'm going to take out what they have in common. So I have a 3 and a 3. So 3 in common, and then I can take out 2 n's from each, have 2 n's in common. So that's going to be times n squared. This one over here, they have a 2 in common. So just a 2 coming out. And then I'm going to multiply or bring these things back together. So 3n squared 3n squared, and then plus the 2 over here. And then left on the inside of this, I have a 3n. And then when you take everything out, remember that there's still that invisible math. You can still multiply these things by 1. All right, so there's still a 1 left over. All right, so that's going to be 3n plus 1. And over here, it's going to be 3n plus 1 as well. Disappear, that's weird. And then bring your stuff back together. So on the outside, so regroup, it's going to be 3n squared plus 2. And then 3n plus 1. All right. And I think that will do it for the GCF, the factor by grouping. We'll see you guys next time when we do more factor trinomials.